Okay. So here's our new calendar. Make sure you turn your homework when you get back. We're going to do 3 days of solve a system by graphing. So we're on day 2, and remember, you're getting that graphing calculator, so you know how to do this. So you probably don't have one at home, so I'll still go through that part of it, briefly talk you through it. But you definitely need to practice. There'll be 2 problems on the test that require you to solve by graphing using a graphing calculator. So make sure you practice that. Homework for tonight will be a worksheet attached to the email. All right, here we go. So this is just a quick review. I mean, nothing new, just a reminder of what we've been doing. So recall that when we solve a system, or when we solve a equation that has 2 variables, what we're doing is we're saying what value for x would produce a value for y. So I can pick any number I want. I just chose 2 at random. Plug that in for x and see what value we get for y. So let's see, 2 times 2 is 4, plus 1 is 5 when I plug that in. So when we plug in the value 2 into this equation for x, we get a value of 5 for y. That is a solution of many solutions. For instance, if I plug in 0 now in for x, 2 times 0 is 0, plus 1 is 1, we get the value 1. So that is another solution. I could continue this process forever. So -3 times 2 is -6. -6 plus 1 is -5. All 3 of these are solutions to that equation right there. And what we found out from the previous chapter is that when you graph those 3 points, it makes a line. And that red line right there not only is the connecting of the dots of those 3 points, but represents all the solutions to that equation. Each point along that red line is a solution to that yellow equation right there, which is why we call that equation a linear equation, because when you graph it, it makes a line. So what would happen if instead of having 1 equation, we had 2 equations? Well, if we graph the first equation and then graph the second equation, we notice that the 2 equations intersect. And where they intersect is the one solution that satisfies both equations. In other words, it's the one solution, the one ordered pair, the one xy that makes both of those equations true. So where those 2 lines intersect is called the solution to a system of linear equations. That point right there is 1, 3. And 1, 3 makes both the yellow and the blue equation true. Check it out. If we plug in x for, or if we plug in 1 for x, 2 times 1 is 2, plus 1 is 3. We get the y value. And on the blue one, 4 times 1 is 4, minus 1 is the 3. So that is the one value that satisfies both equations. So this entire chapter is about finding one solution to 2 equations, and it just so happens graphically that means where the 2 lines intersect. Further, what we talked about is that the intersection is not the only thing that can happen when you have 2 lines. Yes, when you graph 2 lines, they can intersect. And when they intersect, they only intersect in 1 point, so therefore there's 1 solution. But 2 lines could be drawn parallel to each other and they would never intersect. Therefore, some systems have no solution, the ones where the lines are parallel. And lastly, it's rare, but it can happen. You can graph the same equation twice. And when you graph the same equation twice, well, then there's an infinite number of solutions. Every single solution to the red one will be a solution to the black one. So those are the 3 possibilities. And lastly, we talked about is that those 3 possibilities, one solution, infinite solutions, or no solutions, has a pattern, and the pattern is in the slope. So when there's one solution, take a look at those 2 lines, well, the 2 slopes have to be different. So if I looked at the 2 equations before I graph them, I can notice whether the slopes are the same or not, as long as it's in the form of y equals mx plus b. And notice the 2 blue lines right there. One, the slope is 2, and one, the slope is -3. If they have different slopes, eventually they're going to intersect. Okay. Secondly, if the 2 lines are parallel, what do we know about parallel for lines from last chapter is that they have the same slopes. So if I looked at the 2 equations, the 2 blue ones right there from the start, I would notice that, look, the slopes are the same. I've got 2 in one and 2 in the other, but the y-intercepts are different. So if the slopes are the same, but the y-intercepts are different, they're parallel lines, no solution. This will save me some time when I'm doing homework. If that's the case, I don't need to graph this. I know there's no solution. And lastly, well, believe it or not, this can happen. If the slopes are the same and the y-intercepts are same, it's the same equation. Therefore, there's infinite solutions. So this is just a not necessarily a shortcut technique or method, but this is something that you should be aware of when I'm going to give you two equations and ask you to solve that system. You should immediately check to see whether the slopes are the same or different. If the slopes are different, there will be a solution. Graph them. If the slopes are the same, it just depends whether the y-intercepts are the same or different. If they're different, well, they're parallel. There's no solutions. Don't graph those. If everything's the same, the slope and the y-intercept, well, then there's infinite solutions. Once again, you don't need to graph that to figure that out. So long as they are in the form of y equals mx plus b, which brings up the last idea. Well, let's do a couple quick ones right here. So let's see, the top left one, the slopes are different. One is 1, one is 4, so therefore there's one solution. Where is the solution? Well, it's where the two lines intersect. We'll do that next. Bottom left there, the slopes are different. Therefore, there's one solution. Where the two lines intersect is the solution. But look at the top right one. Look, the slopes are the same, -1/2, -1/2, but the y-intercepts are different. Therefore, that would be no solutions. And then the very last one, well, if you did not notice that both of those equations are the same, the slopes are the same, the y-intercepts are the same, therefore it would be infinite solutions. So the two on the left, you got to graph to find the answer. The two on the right, you don't need to graph to get to an answer, and you will see that tonight for homework. There's one last special case, or a couple more special case ones to talk about. How about that? The first one is just a quick reminder that all horizontal lines are the form of y equals k, where k is just a number, and that's the number where it goes to the y-axis. Notice it goes to the y-axis there at 2. So yes, you will have to still graph those, and you'll still have to graph vertical lines as well too. Vertical lines are the form of x equals k, where k is that number where the line goes through the x-axis. Okay, so yes, tonight we'll have just a couple of them that have involved horizontal and vertical lines, and they're not too challenging to find the intersection. All right, so how does all this how does all of this work? Well, I'm going to hand you two equations and ask you to solve that system. Step number 1, pick an equation, top or bottom. I'm going to go with the top one. It doesn't matter which one you pick. Graph that equation. Remember, to graph an equation of the form y equals mx plus b, we graph the y-intercept first. The y-intercept for the top line is 2, so we put a dot on 2 on the y-axis, not the x-axis. Let's see, the slope is, what number is attached to x is 1, 1 over 1, so up 1 over 1, up 1 over 1. Put about 2 points, and then don't put any more until we see where the second line is. You may be putting points for no reason. So if we go to the second equation, let's see, the y-intercept is -2, and the slope is 3. So up from that blue dot, 3 and then over 1. So up 3 squares over 1. Ooh, I can see where the intersection is happening. Go up 3 over 1 more time. And look, I've got a red dot on top of a blue dot, and that's where the two lines would intersect. And where they intersect is your answer. So that's at 2, 4. Now, there is a check step if you'd like to. We just plug in 2, 4 into both equations and make sure it makes it true. Let's see. If we plug in x value of 2 to the top one, 2 plus 2 is 4. If we plug 2 into the bottom one, 3 times 2 is 6. 6 minus 2 is 4. And that's how you can check whether that's the answer or not. Let's do another one. All right, same first equation, x plus 2. So let's see, a dot on +2, a slope of 1. I'm going to put about 3 points. I'm not going to put any more because I don't know where the intersection is until I graph the second equation. So graphing the second equation, the y-intercept is a +4. And if we go up, the slope would be 2. If we go up 2 over 1 and up 2 over 1, we're not going to remotely come to an intersection point. So it must be in the other direction. So we do the opposite of the slope. It's not just make it negative, it's make both of the top and the bottom opposite. So instead of being 2 over 1, it would be -2 over -1. So I go down 2 and then left 1. And notice one more dot, maybe I'll find the intersection point. And then I'll continue that pattern with the blue dot. So down 1 over 1 and then down. Oh, look, the red dot and the blue dot line up perfectly. That's your intersection point. And that's why I say don't draw your lines until you find out where the dots intersect. So what's that point? Be careful there. -2, 0 would be that point. Check step, sure. Throw in -2. -2 plus 2 is 0. 2 times -2 is -4. -4 plus 4 is 0. So that's my check step of both of those. That's how I can be confident. One last special case one I want to point out to you is the horizontal vertical, and when it's not in the form of y equals mx plus b. So let's see this one right here. So let's see, it says y equals 3. Well, we know y equals 3 is a horizontal line at a y value of 3. So there's my y value of 3. This is the one where I'd say go ahead and draw your line because there's a nice straight line. There's no, we can do that very quickly. We don't have to apply slope or anything like that. Second equation, let's see, a y-intercept of +1 and a slope of down 2 over 1. Well, if I continue in that direction, I'm not making any progress right there. So I know it's not in that direction. It's in the other direction. So go up 2 over 1 and looky there. We found the intersection point. So that's -1, 3, -1, 3. Now notice I can't do a check step on the blue line because there's no x value, but look what it literally says. It says that the y is the value 3, and that's what my point says, as a y value of 3. On the other colored one, let's see, -1 times -2 is 2, 2 plus 1 is 3. How about one with a vertical line? So x equals 3 is a vertical line through the x value 3. Same thing with the other line. Let's see, 1 is the y-intercept and -2 over 1. Oh, I can see where that intersection is. Go down 2 over 1 and do it one more time. And there we go. They intersect right there. What's that? That 3, -1, 2, 3, 4, 5. 3 negative. That's wrong. It should say 3, -5. 3, -5. All right. So there we go. The only but here is that what happens if the equations are not in the form of y equals mx plus b? Well, you got to force them into y equals mx plus b. So let's see, let's force them. So I'm going to either equation first. I'll take the blue one first, and that's going to do a little bit of algebra. So I needed to say y equals mx plus b. I need to get rid of that 2x. I'm not going to do it by division. I'm doing it by subtraction. So I'm going to subtract 2x from both sides. I'm going to write the -2x first. So I'm going to say y is equal to -2x plus 3. Because remember, I wanted to say y equals mx plus b. There we go. Take the second equation. It's always going to be the same pattern. Get rid of x first through addition or subtraction. So let's see. I got to subtract x from both sides. So I would get 3y is equal to -x plus 6. And then I need to get rid of that 3. So I needed to not subtract or add. I need to divide everything by 3. So everything gets divided by 3. The 3's would cancel on the left. Don't be alarmed. You got a fraction there. It's okay. We like, hey, that's m is the slope. So we like that fraction to be, or that value to be a fraction because we can see the slope really easy. 6 divided by 3 is 2. So now I'm going to take those two, blue and whatever color that is, and I'm going to graph those two. I'm not going to graph them right now, but we've done a bunch of those. Take those two lines, graph them. Wherever they intersect is the answer. Make sense? All right, and as always, the last thing I'm going to show you is where you got to be able to do this with a calculator kick. So can you do this with a calculator? You sure can. You sure can. So how do you do this? Well, okay, this is going to be weird. I'm going to talk to you over the internet here. And actually, I can show you. Let me just share this. I haven't done this in a while. Give me a second. I have a program that'll do this for us. If it wants to start. There it goes. All right, so I'm going to pick, let's see, I'm going to pick the following equation. Write this down, unless you have it calculated. So y equals x plus 2, and y equals 2x plus 4. And we're going to solve, we've already solved this using graph. Now we're going to solve it with a calculator. All right, so here's the calculator. Here's the screen. The first thing we want to do is we want to hit the y equals button. So on the upper left-hand side is the y equals button. Oh, I'm not sharing this, am I? Let me share this. There, now that makes sense. So what are you looking at? This is a picture of the graphing calculator, and in the middle here where my cursor is going around, that's the screen. So I hit the y equals button up here. So normally it looks like this. You know, you did something like, I don't know, 7 times 9. You got something going on there. Now I'm going to hit the y equals button. Let me clear the bottom. I'll show you the keystrokes. I'll just show you what buttons I'm pressing. So I hit the y equals button. That's what pops up. So we're going to type in the equation. So the equation is y is equal to x. There's the x button right there. plus 2. If it's a negative, you need to use the negative button. So this right here, I'm not typing in anything. Anyway, oh, there we go. Well, let me try that again. Okay, so y is equal to x plus 2. There we go. Now you can either hit the down arrow or you can hit enter. Either one works. And now for our second equation. Our second equation is, now if it was negative, I would hit the not the minus button, but the negative button. That's the only weird thing about TI is they want you to hit the negative button for negative. In this case, it's 2x plus 4. So 2x plus 4. So I have both equations typed in. I don't have to hit enter. You can if you want, or down arrow. You don't have to. Next thing I'm going to do is I'm going to hit the graph button. The graph button is in the top right. And I haven't used this in a while, so my window or my zoom is all messed up. If you don't see the two lines, always go to zoom. The zoom button is up here. It's highlighted in red right here. I'm going to go to zoom standard, which is either scroll down to 6 and hit enter, or just hit 6. Ooh, look at that. There's my two lines. I can already see where they intersect. But I can have the calculator tell us precisely where they intersect. So to do that, it's the look above the trace button right here. And above the trace button in blue, it says calc. So I'm going to hit second because it's blue, and then calc. And that's where my menu for intersection. Intersection is option number 5. It's going to ask me which lines do I want to use. So there, I want to use the blue one. I hit enter. I want to use the red one, enter. And it automatically selects those. And then it says guess. So I'm going to hit enter a third time. It's not really guessing. It's doing the calculation. And notice there in red at the bottom, it says the answer is -20, which we already knew because we did that one manually. So that's how it's done. Now, this works great when the equations are really weird. So even if it's a weird one and it has a large number, so let's say it said 50x. Whoops, I didn't put an x. So if it said 50x minus 1.2, and this one, the second one, let's see, says something like, I don't know, negative. I'm going to use the negative button. So negative 0.36x negative. Let me try that again. Negative 0.36x plus 4. How about that? So this is a really ugly one. You're not solving this by graphing or by doing it by hand. So when we graph this, we may not even, well, yeah, I do see an intersection right there. But sometimes you may be, I don't know, zoomed in way down here. I'll just go ahead and hit a zoom in right here. So if I'm zoom in way down there, I may not even see the intersection. So whenever that happens, step number 1 is zoom. There's lots of zoom options right here. One of them that I like is always zoom fit. And it will automatically know, I don't know how it knows, but it knows it wants you to look for the intersection. And there we go. There's a zoom fit. Zoom standard is also another nice one. So zoom number 6, that's a zoom standard as well too. And notice those two representations don't even look like the same one. Notice on the previous one, zoom fit, it really stretched out the x-axis, right? Notice, or I'm sorry, the y-axis. Notice it really zoomed out the y-axis. And it didn't zoom in on the X one. So zoom standard is usually the one that most people use. So there we go, zoom standard. Okay, so let's see where they intersect. So let's see, second, calculate. Intersection is number 5, so we select number 5. It's always going to put the cursor on the first curve. It's always going to put the cursor on the second curve. It's always going to say guess. You hit it, and then, I mean, notice I put in really weird numbers, which is why we're going to get really weird decimal answers. But that's the power of graphing, is it will always tell you the answer. The only thing you can't do with a graphing calculator is you can't put in a vertical line. You can only put in lines of the form y equals mx plus b. So if your equation is not in y equals mx plus b, slope-intercept form, if it's in standard form, you'd have to do that math yourself. And if you're going to do your math yourself, you might as well do it by hand. You've already gone through the work. So I realize you may not get practice on this one because you don't have a calculator, but we'll get that done when you get back to school. And how do we want to finish this up? Let's see. We want to finish this up by saying, going back to the presentation, just to show you the homework one more time. So all we did in class is we graphed a couple of these with the graphing calculator. So Just remember, before you do any of this, just look to see if the slopes are different. You should not be doing any work if the slopes are the same. So if the slopes are different, it's going to have an answer, right? You can certainly, if you go home and use a graphing calculator, you can certainly check your work with the graphing calculator, but you got to make sure you can be able to do this by hand. So that's your homework, and that'll conclude this part. And I will see you when you get back.